Hello there, Mr. Sutton here, bringing you the IM3 Honors 4-7 lesson on systems of inequalities. In this one, we will take a look at solving and graphing systems of both linear and quadratic inequalities. And as a real-life application, we're going to figure out areas of potential conflict within a city. For your warm-up, we're going to do some two-dimensional inequality review. So go ahead and fill in the blanks as best you can on your guided notes, and then go ahead and graph these inequalities and shade where you need to for each of them. All right, let's see how we did. So remember, there's two types of lines and dots. When you have an equals in your inequality, either greater than or equal to or less than or equal to, we have a solid line and solid dots. No equals, we're just going to use less than or greater than and a dashed line for that. In terms of shading, it all depends on which variable you're talking about. If you've got y less than something, you shade below. Y greater than, remember, we have to shade above. And then if you have the left-right variable, the x less than, we're shading left, x greater than, shading right. We only have to worry about this one for vertical lines, but we see them from time to time. All right, let's try graphing this. So for our first inequality, we've got the equals, y-intercept at 1, so that can be a solid dot at 1, and then a slope of positive 1 over 1, so we're going up 1, right 1. Solid line through solid dots. We have greater than, y is the up-down variable, so we're going to shade up, shade above, so up here. For this next one, this is a vertical line if you think back to Hoy, Vux, vertical if you just have an x. Vertical line through x equals 1. This is going to be a dashed line because there is no equals, so here's our vertical line. And since we're pointing to the right, we're going to shade to the right on this one. Now we're not quite done. The actual solution to a system of inequalities is going to be where the shadings overlap. So wherever that happens, shade it a little darker. And you'll notice here that when I was doing my original shadings, for the first one I did these kind of pointing this way sort of shading lines, and for the other way I shaded in kind of a different direction. That way I can tell better where they're overlapping. So wherever that is, shade it a little bit darker, and then that is our system of solutions here. So the basic idea on all of these is graph them, shade, and then shade even darker where they overlap. Try this one on your own. All right, let's see where we got. For this first one, we just have a line, solid dot at the y-intercept of 0, and then we're going up 2 over 1, solid line through those. Y greater than, so we shade above. Next, let's tackle this one. Now, this is a parabola, and it's in standard form. So we're going to first find the vertex with negative b over 2a, and then we'll use the y-intercept and some symmetry. So negative b over 2a, that'll give us the x value of the vertex. So that's going to be negative 2 over 2 times negative 1. So 2 over negative 2 then, which comes out to negative 1. Plugging that back into the original to get the y value of the vertex, we're going to have negative 1 squared minus 2 times negative 1. This is all negative 1 over here, plus 2, so that comes out to positive 1. So our vertex then is going to be negative 1 comma positive 1. Now it's time to make a decision on dots. No equals, so we have an open dot at negative 1 comma 1. We have a y-intercept of, well, there's no constant over here, so that's going to be 0 over here. And then we draw a branch going through that way, and we draw a symmetrical branch going through this symmetrical point that's away from our axis of symmetry. So this y-intercept is 1 to the right, so we're going to go 1 to the left over here. We have y less than, so we have to shade underneath the parabola, wherever that is. It doesn't matter if it's inside or outside. Again, it's all about below or above. So here we're going below. And the only thing that we shaded for both of these is this little sliver inside here, so that is our final solution for this one. So where, you might be wondering, could this system of inequality business be useful in real life? Well, let's say we have two rival gangs, the quads and the cubes. Maybe they're dancing gangs, I'm not really sure. Their turfs can be described by the following inequalities, where we have x is blocks east and y is blocks north of, say, the local McDonald's, whatever.
So here's the quads, that's their territory described by this inequality, and here's the territory of the cubes. Now the police want to pay extra close attention to the places where these territories overlap. Hint, hint, nudge, nudge. So we can head off conflicts before they start. Where should they focus their efforts? So we have to solve this system of inequalities now. So kind of an ironic problem, even though they're both, one's called the quads and the other's called the cubes. This is actually also quadratic. You've got two parabolas to graph and solve the inequality for. So pause the video and do that to the best of your ability. All right, let's tackle our first parabola. Negative b over 2a. So we've got negative 6 over 2 times negative 3. That's going to be 1. Plugging 1 back in. We've got negative 3 plus 6, which is positive 3, plus 2 gives us a grand total of 5. So vertex at 1, 5. No equals, so we have an open dot there at 1, 5. And now for the y-intercept, we have 2. So that'll be right there. Draw a branch through there. Draw the symmetrical branch going the other way, and it's going to go through 2, 2. That's the same distance away from your axis of symmetry. Less than, so we're going to shade below. And we move on to the next parabola. Negative b over 2a for this one, we've got negative 2 over 2 times 1. So that's going to come out to positive 1 again. Plugging that in for the y value, we've got 1 minus 2 is negative 1, plus 3 is positive 2. So vertex at 1, 2. Still open dots because there's no equals. So here we are. Y-intercept is 3 over up here. So we draw a branch. Now be careful. This right here at 1, 2 is the vertex, and that's why I'm having you guys write this out here so you remember. So our branch has to start at the vertex and go up through the y-intercept that way, and then we'll draw the symmetrical branch going the other way. Now for this one we had greater than, so we have to shade above, and then the overlapping region that the police have to pay attention to so we can break up these little dance competitions right in there. That's all for systems. Hopefully now armed with systems of inequalities, you too can make the world a safer place so no one breaks an ankle having too much fun dancing. Until next time, this is Mr. Sutton signing off.